Right, so the recording has started. So this is I will present some slides about the third round of the assignments. So this round's about model validation and model selection. And what we're trying to answer here is how can we be certain that the model we have trained can generalize on real world examples. So like when we deploy the model in an application, how do we know that it will indeed perform good? So model validation is a set of techniques that are used to make sure the model is able to generalize. And before we used to calculate the training error as a way to quantify the performance, but we will see that this is not a good way to measure the performance because the metric is calculated only on already seen data. So we don't know we have no idea how the model will perform on unseen data. Yeah, so how can we estimate the performance on the new data? And then can we change the ML model to give it better generalization capabilities? So like the first question is about model validation. The second one is about selection, or how can we change the model itself. Here I also have some additional material. These are pretty helpful. I also saw them when I started out. So the learning goals of this round are learn that the training error is not a good quality measure for an ML model. Then we will learn about validation sets and how to calculate the validation error. And we will explain why the validation error is more useful than the training error. And then based on that, how can we choose the best model? Like let's say we have different models and we want to choose the best one that we assume will be able to generalize more. And we will also briefly talk about regularization, which is a soft variant of model selection, or we will discuss it later. Okay, so as we already said, model validation refers to quantification of the predictive capability of an ML model. So the idea here is that many models tend to overfit the data, which means that they simply learn what they have been shown. Like this, you can think of that as simple memorization of the mapping of the features to the labels. So that's not actual learning, that's just memorizing by heart. And that's not what we want to have in our models. So this is called overfitting. And in case of overfitting, we will see a very low training error, which would mean that the model is indeed good, but instead it just remembers what it has already seen. So instead, what we do, here is an example. So as you can see, this is the degree of a polynomial. So with a degree 1, we have this line, and with a degree 4, we have this one. So with a degree 4, we get a model that passes through every possible data point. But with a degree 1, the model only passes through like only one data point. So the training error with a degree 4 is 0, because like the model correctly classifies every data point here, 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 and here. But then when we have a separate set, let's say that the validation set represents real world examples, then as you can see, the model with degree 4 is way off. And the model with degree 1, on the other hand, is like, well, at least it's closer. It's not good, but it's closer. And that's overfitting. So with degree 4, it just memorized the data. And how do we create a validation set? So usually it's just a portion of the initial data set. And the recommended split is to use about 20% or maybe even 30% as validation data, and the rest as training data. So what we do is we first train on the training data, and we calculate the training error. And then we, after like the training is done, we evaluate the model on the validation data. And this validation performance, validation error will be a better indication of how able the model is to generalize. Yeah. Um, if you have any questions, feel free to interrupt me. So I guess I will continue for now. And yeah, this is also in the round 3 notebook. So you have the initial data set, and then you take a portion for the training set and portion for the validation set. Here, the split is not 20 or 30% of the validation set, but these numbers are the ones that are mostly used. Okay. So in the round 3 notebook, you also have a similar example as in round 2. And in round 2, you tested your models on different sets of features. So yeah, like the first model was trained on 1 feature, the second on 2 features, and so on. And now what we what we want to answer is, how can we make the prediction better? Like, how do we know which one of these models is the best? How do we know how many features is the best number of features? So what we do is we get a validation set. So the training error always favors the models using more features because it will be easier to feed this data. But that isn't a good indication of the generalization capabilities. So as you can see here on the validation set, the performance is not always like decreasing when we increase the features. On the other hand, on the training set, it always decreases, but that's just some bias. And like if we were to use this image as a way to choose the best number of features, we would go with 2 features as being the optimal number of features. But maybe you can already see a caveat here, like since this training and validation split is random, then maybe we get a model that is just lucky enough and knows how to predict the validation set. Yeah, so like in the previous image, we saw that the validation error was lower than the training error, which is not really possible. And the model was just lucky. So this is solved by what's known as Kfold Crossvalidation. And it's just a fancy way of saying averaging multiple validation errors. So what do we do? Like for now, ignore this test data, and we will only focus on the training data. So at first, we split the data into k folds. So here we have k equals 5, and we get these different folds. So first we keep the first fold for validation, and we use the rest for training. Second, we keep the second fold for validation, the rest for training, and so on and so on. And this way we get 5 different validation errors, and then we just average them. So yeah, like if you like, here is the new image, new plot for the errors. So again, 2 is the best number of features, but now we see that the previous image was like contained a lot of noise. So yeah, again, we would go with 2 in this case. Yeah, so some further notes. If we select a model based on this validation error, then we will end up selecting the model that happens to fit the validation set better. And to avoid this, we usually also use another data set, which is called the test set, and is what I showed you in the previous image. So the test set is only used for the final model, like after you you, for example, tune the degree of the polynomial or something like that, or tune the number of features you want to use. Then you validate the whole model, the final model, the one that you chose, you validate it on a test set. Yeah, and the test set usually has to be as representative of the real world as possible. Okay, so let's briefly also discuss about regularization. So the goal here is to create models that generalize better. And what the regularization does is it penalizes very complex predictor functions. So here we have the average loss. This is the mean squared error, the squared error anyway. And what we do in regularization is we add this term here. So this is a weight factor alpha, and this is the like regularization function. Yeah. So we will see an example now. So like these two are probably the most commonly used regularization terms. So it's either the L1 or L2 norms of the weights. And the intuition behind it is that the complexity of the predictor increases along with the magnitude of the weights of the parameters. So this, you can think of this as an extra penalty to very high weight. So if like feature X1 has a very high W1 weight, then W1 squared will be huge, and then we will have to penalize this particular weight, and we will get it lower. Yeah, and this alpha hyperparameter that we showed, well, alpha is a tuning parameter that is called the hyperparameter. And what's a hyperparameter is like a very generic parameter that like you decide before you start training the model, and then maybe you want to change it a bit to get better performance. So it's just something that's not constant. It's something that it probably changes with the problem that you have to solve. And that's what we usually try out many different values of these hyperparameters. So in this case, we will try many different values of alpha, and we will see which one results in the best model. So in the best results in the validation set, for example. And this is known as hyperparameter tuning, and you will probably see this term when you Google related stuff or something. Yeah, and in linear regression, a way to apply regularization is this ridge regression, and it uses the L2 norm of the weights. So the cost function is modified to the following. We have the classical, like the traditional first term, and then we have the plus alpha and the L2 norm. And here, similarly for lasso, we are using the L1 norm. And yeah, so the intuition behind lasso is that by not squaring the feature weights, it penalizes both large and small feature weights proportionally. So in some cases, we may even end up with a weight of 0 in some features. So that would mean that this feature is like not important in order to predict the label. So this can also be used in feature selections. Like if you want to decide which features are the best, then you can use lasso regression. And the features that end up having a weight of 0 would be like the most irrelevant ones, and you could like drop them or something. Yeah, so that's pretty much it. It was very fast, I guess. But yeah, there's not much more on the theoretical front. And the notebook is like very well explained. So like it has every theoretical stuff that I mentioned. It's also in the notebook. Yeah. Do you have any questions?
For the first assignment, the deadline is on 25th, right?
I don't remember, to be honest, but
Okay, it's just on the website, it says 25th, and then for the round 2, it says also 25th, so I thought maybe there is a mistyping.
yeah, I think that for the first 2 rounds it's the same deadline, and then you have 2 weeks for the other assignments, for the next ones.
Okay, thanks. And the total grade will be depending only on the assignments, right?
Yeah. Oh yeah, actually, there's gonna be a project, but it's gonna be only bonus points. So if you didn't get full points on some assignment, then you can do this extra project work to get full points. It will be 10 extra points.
Okay, and the lectures are twice a week, right? Monday and Thursday.
No, there's no lecture on Monday. It's only Thursday.
Oh, but before there was 2
Yeah,
times.
this was the introduction lecture, just to show you how the course works.
Okay, okay, I see.
Yeah, and on Thursdays it's not really a lecture, it's like a lab session. Yeah.
Like a previous week, there was also like a lecture on Monday or like a
Yeah, that was like introduction, and uh, yeah, I think I don't remember. You mean the one that Samsi did, right?
yes.
Yeah, that was about round 1. I don't remember why it happened on Monday.
But from now on, it will be only on Thursday, right?
Yeah. It's on Thursdays. Yeah.
Okay, thank you.
Is there any other question? Um, about the material, about the theory? Um, yeah, but again, as I said, these are all in the notebook itself, and I will also upload these slides. So you will have all this theory. And yeah, as I said about the project, it will be announced in the next few weeks. So the idea is that you will pick a project, like you will pick a topic yourself, something that you want to classify, for example. Let's say classify the temperature of the next day, like predict the temperature of the next day, or classify like the sentiment of something, I don't know. And yeah, you will have to like analyze what you did and provide a report of 1 to 2 pages, as far as I remember. And it's gonna be 10 bonus points out of 60. So yeah, it's a lot of points. And yeah, if you fail one assignment, this will help you recover your grade. But I think I will stop recording now.